Icebergs look enormous, but what you see is just the tip. Nearly 90% of every iceberg is hidden beneath the surface. Why? The answer is pure physics. This massive, floating mountain of ice is mostly invisible, lurking in the cold, dark water. It's a natural wonder that combines beauty with immense power, and the science behind it is fascinating. Welcome back to Understanding the World. Today, we're diving deep to uncover why icebergs float, why the vast majority of their mass is underwater, and what makes them so mysteriously beautiful and dangerous. We'll explore the physics of buoyancy, the unique properties of water, and how these colossal ice giants are connected to our planet's changing climate. So grab your Parker and let's get started. So what exactly is an iceberg? They are massive pieces of ice that have broken off from glaciers or ice shelves, a process called calving. Once free, they begin a slow, majestic journey, drifting through the world's coldest oceans. Carried by powerful currents, they can travel for thousands of miles, slowly melting as they move into warmer waters. But their simple appearance hides a complex secret rooted in the fundamental laws of physics. The real story isn't what's happening on the surface. It's what's happening underneath, where the true scale of these frozen giants is revealed. Everything that floats, from a rubber duck to a massive ship, depends on density. Density is simply how much stuff, or mass, is packed into a given space or volume. And here's the key: ice is about 10% less dense than liquid seawater. This slight difference is everything. Because ice is less dense, it floats. But because it's only slightly less dense, it doesn't float very high. Archimedes' principle tells us that the buoyant force pushing up on the iceberg is equal to the weight of the water it displaces. To balance the iceberg's total weight, it needs to displace a huge volume of water, forcing about 90% of its mass to sink below the surface. This creates that iconic and often deceptive iceberg shape. But wait, why is solid ice less dense than liquid water? This is a really unusual property. For most substances, the solid form is denser than the liquid form. Water is a special exception. When water freezes, its molecules arrange themselves into a rigid, crystalline lattice structure. This crystal formation actually takes up more space than the free-flowing molecules in liquid water. More space for the same amount of mass means lower density. It's the same reason why ice cubes float in your drink instead of sinking to the bottom, and it's why these literal mountains of ice can float in the sea. Icebergs don't just come in one shape. They can be tabular, meaning flat and wide, or non-tabular, with shapes that are domed, jagged, or even look like spires. But no matter the shape you see above water, the hidden part below is always much larger and far more unpredictable. Underwater, an iceberg can have massive, unseen extensions, caves, and submerged ledges. This hidden danger is what makes them so hazardous for ships. The most famous example, of course, is the Titanic, which struck the submerged part of an iceberg, leading to one of history's most tragic maritime disasters. Today, icebergs are more than just a navigational hazard. They're also a critical indicator of our planet's health. As global temperatures rise, glaciers and ice sheets are melting at an accelerated rate. This means more icebergs are calving into the ocean. At the same time, warmer ocean waters cause these icebergs to melt faster. By tracking their movement and melt rates, scientists can gather vital data about ocean currents, temperature patterns, and the overall impact of climate change. They are like giant, natural thermometers, telling us a story about our warming world. So the next time you see a picture of an iceberg, remember what lies beneath. You're only looking at a tiny fraction of a massive, frozen world hidden under the waves. It's a powerful reminder that sometimes the most important part of the story is the one you can't see. What other ocean phenomena should we explain in our next videos? Let us know in the comments. If you enjoyed this deep dive, give this video a like and be sure to subscribe to Understanding the World and hit the notification bell. Thanks for watching, and we'll see you next time for more science explained simply.